Testing, testing, testing. Yikes. Let's see if this is any good. Yeah. Doesn't seem to be good. It seems to be, like, marginally working at the moment. So, oi. YouTube is not receiving enough video to maintain smooth streaming. As such, viewers will experience... Alright. Hello. Testing, testing, testing. Are we back? Are we back? Looks like we're okay. Are we okay? Okay, I think we are okay. Wonderful! So, good. I went and had a word with the ghost that's currently living in the router. It's the ghost of Sean Connery. He just, you know, recently snuck into my router and it was like, oh, this looks like a good place to spend my At this point, is it worth it to keep trying? Okay. This is going to continue to be a problem. Yeah, the slides are up on Avenue. This is going to continue to be a problem, so this is what I'm going to do. Give me 3 or 4 minutes, and I'm going to try a full system restart. I'm going to try turning it off and on again. Hopefully that fixes the problem. I apologize, everyone, for this. These technical problems. I'm not sure what's causing it, but maybe restarting my system will be the fix. I will be back momentarily. Testing, testing, testing. Hello, testing, testing. Maybe we're back. That's the power of Linux, folks. You can reset your computer really quickly. Ah, I'm not 15 minutes late yet. It's only 9:44. Okay. Okay. There we go. We are having class. I'm not late. Ha! There we go. Although, thank you for that vote of confidence. Whatever you do, nobody click that link, please. Stop confirming false information. Anyway, hello. Hello, everybody. Anyway, so JSON files. Looks like the stream might be fixed. Hopefully that is the case. So, in the same way that we have a CSV module for working with CSV files, we have a JSON module for working with JSON files. I think I already demonstrated this, actually, with the assignment. But just to quickly recap, in order to use the JSON library to load JSON files, those operations actually are on strings rather than file streams. You have to acquire the file in the way that you would normally acquire a file. You would just load the whole thing into a single string variable, and then you have to call the JSON.loads load string method on that. So there you go. Similarly, you can convert any dictionary or list of dictionaries, etc., into a JSON string using json.dumps, which is kind of a funny name for a method, but there you go. If you want, you can then write this to a file in the normal way. So if we imagine we have a dictionary, the dictionary, the value at Key Studio is Disney, movies is a list, we've got Beauty and the Beast and the Lion King, and we then open a animated.json file in write mode as file handle. We can take this data structure, convert it to a string using json.dumps, and then write it to the file handle in the way that you would normally write a string to a file handle. Nah. Am I terribly out of sync? Let's see. Is it playing? It's not even playing. Jeez. That'll help. Okay. Let's see. I think I can nail this here. Ah, that made it. How bad is the sync delay? Can I turn it a little louder as well? I could do that, yes. That's close enough. It's weird. Sometimes it's not necessarily that people are leaving. Sometimes it just it disconnects from the server. I don't know. It's weird. Anyway, that doesn't necessarily mean people are leaving. Could I record it on my own and post it after? I don't know. We'll see if we can keep going. Anyway, let's just finish this set of slides. JSON data sources. If you're interested in playing around with JSON data, there are many websites that will provide you access to their data in some sort of automated way, specifically via a Web Application Programming Interface, or API, Application Programming Interface. Once you up there in using software, APIs become very, very useful for you. Data returned from the web APIs is often in JSON format. You can get data in this manner off of things such as Facebook, Instagram, and Twitter. Here is an example of such data. This is way too small to read, but as you saw from yesterday's or Tuesday's lecture, it's also entirely possible to get this data from your assignments themselves are this style of data as well. Alright, so let's talk about XML, or the Extensible Markup Language. Oh my god. Is the audio at least coming through? Upload bandwidth problems. Like, internet test. Well, anyway. Sounds like I'm back. Am I back? Maybe. I don't know. Like, this is very strange, and I apologize for all of this, folks. I don't know why the internet decided today of all days, and Tuesday of all Tuesdays. But are we okay now? Are we okay? That looks okay. Okay. Oh boy. Alright. So, the Extensible Markup Language, XML, it's a plain text format for formatting data that is meant to be both machine-readable and human-readable, although in my personal opinion it accomplishes kind of neither of those things. It's got a hierarchical structure similar to a JSON file, and it's commonly used for transmitting objects between applications. The one thing about it is it's somewhat difficult to actually construct. You're not going to be tested on XML files. This is primarily for your own interests. Probably most of you at some point have played around with HTML, and XML is kind of like HTML, but not. It's a little bit more general purpose. The basic format is that everything in an XML file is wrapped in tags, which denote what the type of the element is. You, just like HTML tags, you start with the angle braces, and then you end with angle braces and a slash. Elements can be nested inside of each other. In fact, that's how XML files produce a hierarchical structure, and elements can have attributes added to their tag definition. So you could add, like, name, date, etc., different fields inside of the tag itself. Similarly to a JSON file, the whitespace doesn't matter, which means that you can use the whitespace to format it in a manner that you find aesthetically pleasing. So, the backup server. Is there a backup server? My god. Yeah, It is literally HTML, but not a document. That's what XML is. So if you were to take the Harry Potter family tree running example that we've been using, we would create a family tree object and end it over here. We would have a person who was born 1980, name, children, each containing a series of persons, etc., etc. Obviously, this one only has one person at the top level of the family tree in it, but you could see how you would add more to the list. It's just to keep it on the slide. So reading and working with XML is actually quite tricky. There's a lot of extra stuff that comes out of parsing an XML file. What that means is that there's a lot of detail in an XML file that's not necessarily the detail that you're looking for to actually translate into a data structure in Python. It can be hard to pull out exactly what you're looking for because of the extra stuff and the difficulty of precisely indicating a particular point in the XML file. So the thing about a JSON file, since the data has been pre-organized into lists and dictionaries have a very specific way of going about finding things in them. We can, for instance, use the in search operator. We can, access things by index, etc., etc. In XML, it's a little bit more tricky. If you wanted to interpret an XML file as a list of as a dictionary or a list of things in dictionaries, you could totally do that, but it's not natively in that format. If you would like to read an XML file, you would import xml.dom.minidom with open potter.xml as file handle. S is equal to fh.read, x is equal to xml.dom.minidom parse string, people is equal to x.getElements by tag name person. For person in people, you can do stuff. But you can see that this is we're using getElements by tag name here rather than simply being able to enter a key into a dictionary. It's roughly the same thing, but not quite the same thing. Again, you're not going to be tested on this. xml.dom.minidom.parseString parses the XML string into an object. GetElements by tag returns an array containing all of the children. So there you go. A lot of websites make a news feed in their recent articles available in an XML-based format called RSS or Atom. Many businesses and government-oriented websites make data available in XML format as well. For example, the Government of Canada has this, which is your Hamilton weather, which is formatted in XML format, and you can see how it would be challenging to read something like this. But that's weather data right there. Looks like for the current day as well. Wednesday, a mix of sun and cloud, high +4. Maybe it's just for the current week. Or maybe that's next Wednesday. Anyway. Boop. How's the stream doing? Yeah. Well, anyway. Again, here's an XML example for the current Bank of Canada US dollars to Canadian dollars exchange rate. There you go. This is a Python script that reads out and parses that information, which, if you want. And, of course, we have HTML, which is the hypertext markup language. Plain text language is used for describing the content of web pages. Every page that you browse on the web is an HTML file. They have a hierarchical structure similar to an XML file, and it is possible to extract HTML files using, the right-click view page source you can take a look at the HTML files anytime you like, actually. Excuse me, on any web page. The problem is that if you're writing programs that rely on these HTML pages having a particular structure, if the vendor of the HTML file somehow changes the format, then it's going to break your algorithm. So you probably don't want to rely on anything that's in an HTML file. It is preferable to use CSV/JSON/XML if available in all cases. To HTML. The programmer joke is that HTML thinks it's a programming... People think HTML is a programming language, and it is definitely not a programming language. People make jokes about it. Anyway, so that's topic 9. Ha 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 ha. Good, good, good. We can move on. Thank goodness. The stream seems to not be messing up too badly at the moment. Okay. So. So we're going to move on to topic 10, visualization. No, that's not what I wanted. This is what I wanted. So, really effective breakdown into categories here. So, there are a number of different libraries for plotting things in Python. However, the one that we're going to be focusing on right now is Matplotlib. Essentially, when we are talking about visualization in this section, we are talking primarily about graphing things. So we're not going to be making video games in this section, unfortunately. But yeah, it's important to be able to represent data, particularly for those of you who may be, you may be in the science faculty, may be looking to get into grad school, and you may be looking to have some statistical packages available to your use that you may wish to use for stuff. This will be one way of going about it. Although, of course, if you're being serious about it, you're probably using R. So, there are many different libraries for plotting in Python. We've got Pylab, Pyplot, and Pandas. We're going to use Pyplot because of its basic syntax, which is object-oriented. We'll use the basic Pyplot interface for this course, but others can be more powerful. Matplotlib is an optional Python set of packages for plotting. It comes pre-installed in Anaconda, and it has been installed in JHub 2. To install on your local computer for use in the idle/Jupyter environment, you can try one of the following. pip3 install matplotlib, python 3m pip install matplotlib. Whatever your installation is, this is how you would go about doing it from the command line. You can get plots from Matplotlib to show up directly in Jupyter notebooks using the Jupyter magic command matplotlib inline. This displays non-interactive images inside of the notebook. So all you do is you include this line at the top of whatever cell that you're executing, and then it'll actually show you your plots in JupyterHub directly. You also have matplotlib nbag, which inserts interactive plots into the notebook that can be dragged around, zoomed in, etc. So let's take a look. Plot a line from a list of points. We have import matplotlib as pyplot. we have a set of x values and we have a set of y values. And that is not the graph that corresponds to that. Oh my goodness. All right. Let's do this in a Python file, then. It's going to fall. There we go. Go to code. Graphs.py. I just need to scoop up the command that writes these things to image files, because that's how I'll be able to see it. There we go. There we go. So, if we execute that code, no such. What did I call it then? Did I save it? I didn't save it. See what the stream is saying. So, oh my goodness. Is it possible to postpone the final exam by a day? No. Sorry. No. Sorry, but the day on which an exam is written is completely not under my control at all. So, there you go. Now, yeah. How come this is notes, it says 9.5, but it is actually 10.5? Because I moved some stuff around. I've used this for integration, like Euler's step pattern for stuff like that. You don't need to know what values put into Python tutor. Yeah, maybe Python tutor would work. Maybe Python tutor will work. Alright. That's Java. Get out of here, Java. I'm sorry, guys. I'm just having the worst day of it today. There we go. Doesn't support Matplotlib. Ah. Do I have Jupyter installed here locally? Yeah. Do I have any good resources for learning C? Yeah, all of the slides I've been doing on learning C, and all of the online lectures. Feel free to take a look. Jupyter path, sure. Let's say test. No such file to directory. Jupyter notebook. Yes, thank you. Okay, maybe this works. New Python 3 notebook. I mean, we'll see. Maybe import. Let's just grab this. Let's grab it from the slide, actually. Copy. That's also... Ah! It worked! There we go. Okay, so we have it working. Thank you very much for your patience, everyone. Sorry, this has been the stream from hell. So, I mean, not to advertise my own material or too much, but if you want to know what the other class that's learning C is doing, they're using this textbook, which is How to Program C 8th edition by Deedle and Deedle. If you're interested in watching the lectures on the if you're interested in watching the lectures on this channel, then absolutely feel free to do it. That'll at least give you a start. Though obviously, like, the assignment material you wouldn't get because it's on its own Jupyter server. Anyway, so this is what that plot looks like. Not this. This is the wrong image. To create a line plot where the y values are computed using a function, we'll have to create a list of y values by editing the function on the x values. So rather than just having, 1, 2, 3, 4, 5, 6, we would make the x values a range from negative 100 to 100. I'm going to do that. There we go. And then the y values will be a function of that. This is, I believe, a list comprehension, which is it's a format that we haven't seen yet. But it's essentially kind of like a inline for loop, and then it formats it all as a list. So if we execute that, you can see we get this very nice curve, which is the plot that's actually there. Now, this is not a continuous line plot. This is a plot of a series of data points that are sufficiently close together that you can see. You can't really tell the difference. Kind of like high polygon graphics. So if we set something like density is equal to 20 rather than 10 or 100, and density and negative density, you can see that that's still pretty good, but let's crank that down a bit more. You can begin to see, if you look very carefully, probably you can't see it on the stream, but this is the point at which you start being able to distinguish the individual lines. here we can definitely start to see the lines forming. You can see them very clearly here, even more clearly there. So yeah, so we have to provide a sufficient number of data points in order for the graph to look continuous. So the issue here is that range can only step by integers, right? This range object, it only divides things up by integers. So if you wanted, for example, to do a bunch of data points in the range from 1 to -1, you know, this would be not the thing that you would be able to use. So we're going to instead create our own fRange function, which does essentially the same thing as range, but it uses floating point numbers rather than integers. There we go. So if we wish to then do an fRange from, say, -1 to 1 by intervals 0.1, you can see that we actually have something more approximating, we have something like a smooth curve, but on a, non-integer scale. We can do it between any two points on the number line. And if you wanted to make that less smooth, you could crank that down, and if you wanted to make it more smooth, you could crank that up. There you go. If we are trying to create a smooth, continuous-looking plot, we have to have sufficient data points using our custom fRange function to create a range stepped by floating point numbers. There you go. So if we want, we can also, up to this point, we've been using x squared as the function that we've been plotting. But of course, you don't have to just use x squared. You can use whatever you like. Math.sin x, for example, will give you, well, you would have to import math, wouldn't you? There you go. On that interval, that's what it looks like, but if we expand the interval out a bit, you can see that we get a regular sine wave. Why don't I teach you C in the winter? Well, I would have to be paid for that. I can't, much as I would like to be able to run any course for anyone that is, sort of whatever they want to learn, it's, I kinda have to be able to get paid for it so I can continue to have a roof over my head. But, next semester it looks like I'm going to be teaching 1MD3 again, and nothing else, so. I'm also going to be, defending next semester, so there you go. Is there a library that can plot graphs of mathematical functions? Yeah, it's this one. This is how you select which which function you want to plot. Does length x values always have to equal the length of y values? Well, that's an interesting idea. Let's see what it does if we append a couple of values to the end here. Looks like yes. Looks like the x values and the y values need to be the same length. So there you go. Question answered. What do I mean by defending next semester? I mean defending my thesis. Incidentally, I think class is over, so I'll take your questions, and then we'll be shutting the stream down. Assuming that the stream doesn't shut itself down this time, but we seem to have been having reasonably continuous. Anyway, yeah. So I am a doctoral candidate within the department. I am not a doctor. That's why whenever you email me, I sign my name Mr. Moore, not Dr. Moore, because I am not yet a doctor. However, I have a thesis that is written and is currently in the comments and editing phase. I haven't had a whole lot of time to work on it this semester, to be honest with you. I've been working pretty long hours just to keep the courses I am responsible for running smoothly. Yeah, so when I defend... So what PhDs do, what PhD students do to get a PhD is they have to defend their thesis, which means that you have to present your thesis in front of a panel of professors. Those professors interrogate your thesis, and you have to defend the fact that the science that you've done is good. So a couple of more questions. What's the general topic of your thesis, if it's not too much to ask? Oh, no, it's not too much to ask. It's applications of theorem proving to hardware description languages. You can't read the thesis because it's not published yet. Part of the process of getting your PhD is that your thesis is eventually published publicly for people to be able to read it, but it's not published publicly until it's, done. As I said, it's still in the editing phase. So, if you're interested, this is all kind of provisional, but applications of formal hardware modeling using BlueSpec system Verilog and prototype verification system. This is my thesis. This is my thesis. It's about 200 pages. In recent years, aging and obsolete controller infrastructure has encouraged the adoption of new processing paradigms in programmable logic controllers, PLCs. Unfortunately, due to the vast difference between past and present processing paradigms at both an abstract and implementation level, proofs of correctness previously produced for older architectures are not applicable to FPGAs. I think that's a spelling mistake in my bloody abstract. As I said, it's still being edited. This is problematic for safety critical applications, especially where regulatory agencies require such proofs, etc., etc., etc. So the general idea is that I wrote a compiler. The compiler takes things that are written for FPGAs, and it produces a logical abstract, like an abstract logical implementation. It's a model. It produces a logical model in a theorem proving system called prototype verification system, which allows you to prove mathematical theorems over it in a semi-automated manner. So you can essentially take certain types, certain classes of hardware descriptions, and you can automatically demonstrate various theorems of correctness over them. Where does it get published? I believe it eventually will get published by the department itself. So, yeah. I believe in the department office. I'm not sure if they still do this because everything's online these days, but in the department office, there's like a wall of previous theses that students have written, which you can, during regular times, I think you can go and ask to see them. I'm pretty sure that every thesis that's ever been written by a student of McMaster is available through the library as well. So, yeah, believe it or not, 200 pages isn't so too terribly long for a thesis. I've seen theses that are upwards of 400 pages, but the thing to keep in mind about those 200 pages is that does not include a listing of the code that I've written. So if you were to include all of the code that I've written and all of the examples, you'd easily double that, probably. All right, am I doing my PhD at McMaster? Yes. Is a mathematical proof system like the one Dr. Farmer did? Possibly. What mathematical proof system did Dr. Farmer use? I wonder. Yeah. Well, I mean, it's 200 pages, but, you know, I've also been working on it for an ungodly amount of time, so. Um, what made me do a PhD? Um, well, it was kind of interesting. Um, because I was doing a master's degree, and the master's degree that I was doing, I quickly realized that my the work that like the project that I was doing as a master's degree was, you know, could easily be expanded to something PhD level, and you know, my supervisor, Dr. Lawford, thought so as well, and so I actually didn't graduate with I didn't actually get a master's degree. I don't actually hold a master's degree. I transferred into the PhD program from the master's program. So, you know, why did I do it? Fame and glory, I guess. I don't know. Um, I don't know. I made the decision like 8 years ago. So, as I said, I've been doing this for an ungodly amount of time. What language did I write the compiler in? I wrote it in Haskell. So, for those of you who think that, you know, I'm down on Haskell because I make fun of it every once in a while, that's not actually true. My my whole thing is written in Haskell. So, let's see. This is the big boy. Um, yeah. This is my compiler. You can see that um, there's quite a lot of it. For those of you who know anything about Haskell, you'll know that Haskell is a hyper-compact. It's a hyper-compact language, so you can express something in Haskell in like 5 lines that takes a very, very long time to a very long time to do in any other language. So I measured it at one point, and I think I've got just shy of 10,000 lines of code through all of the files that went into the translator. And like, yeah, that's just in that module. In total, it's about 10,000 lines of code. That's like the biggest module. But I think, like, if you take roughly I would say it's probably around accurate if you would consider 1 line of Haskell to be around 20 lines of C on average. Then, you know, that would be 200,000 lines of code. Screw 200 pages. That's the long part of the thesis. Yeah. Yeah. Those of you who have some appreciation for Haskell will understand that. And you know what? The other thing is, like, I over the course of time, I had to throw the thing out almost completely about 3 or 4 times over the course of the time I've been working on the project. So, and just kind of start over from scratch. So the total number of lines in total is much larger than that. Why not an interpreter? That's a good question. That's a very interesting question. If I were going to make an interpreter rather than a translator, basically I would have had to have implemented the theorem proving part of it myself, and that is like implementing a theorem prover is that's a thesis right there, regardless as to whether you were actually trying to apply it to anything. So let's see what this thing is. The one that I use is PVS. It's a little bit old now. It wasn't as old when I used it originally. Introduction. It's a little bit like this. It's the um so the this imps this looks like it's more specifically aimed at um like mathematical proofs from the perspective of mathematics. When I say mathematical proof, I'm really talking more logical proof. So at some point, you guys are going to get into, and I realize I'm going over time, but you guys seem interested. Um, the the thing that I'm doing is more on the order of logical proof, which is related to predicate logic. So let me see if I. Oh my goodness, do I have anything in here about it? Maybe I do. I should have something in the thesis about it. Well, anyway. At any rate, does it compile to bytecode? No, it doesn't. It's actually not even an. I used to be able to claim that it was just a syntactic manipulation, but I don't think I have the right to claim that anymore because one of the fundamental problems that I ran into was that the semantic that I was coming from and the semantic that I was going into were those were sufficiently disparate. They were sufficiently distant and distinct that, although I originally thought I would be able to do it without interpretation of the underlying code itself, I could just perform some syntactic manipulations and get something out that would run in PVS. I ended up having to do a lot more simulation than I thought I originally would have to. So I don't think I can quite claim that the thing is simply a static analysis engine anymore. But it's still it's the degree to which this is the degree to which it's implementing a semantic is still pretty limited. Like, it doesn't interpret expressions. It doesn't interpret or execute expressions. It takes expressions and it transfers them over directly. Yeah, the work is actually based on earlier work by a couple of blokes out of the University of Manchester, who, for one reason or another, believed that you could accurately simulate the semantics of the BlueSpec language by not even addressing how individual action executions are composed into clock cycle semantics. So, anyway, that's a rough overview of my thesis. Hopefully, early next semester, everything will be together and we can get it defended, and then I will be able to sign Dr. Moore at the end of my emails rather than Mr. Moore. But, yeah, anyway. Take her easy, folks. Have a good rest of your Thursday. I'll talk to you guys again soon. I'm glad that you find it interesting. Yeah. After so many years of it, I'm not sure I find it as interesting anymore. I think I'd like to move on to the next thing. But anyway, take her easy, folks.